All right, we're going to look at the titration practice that we were working on Friday. So we're considering the titration of this volume and this concentration of acetic acid with NaOH. So here, because I have two pieces of information about my acetic acid, I know that in my titration, it's in the Erlenmeyer flask, and my sodium hydroxide is in my burette. Before the titration begins, I'm not considering anything about NaOH. I'm only concerned with what is my pH of what's in my Erlenmeyer flask. So I'm going to take the concentration given to me, and I'm going to use 8.4 to solve this question. So I know that initially I have this. I can check my approximation method by taking 0.1 divided by my Ka. Since it's greater than 500, I know after the change, my equilibrium concentration will be the same as my initial. I'm producing acetate and hydronium. Hydronium is important because it's going to help us solve for our pH. So now that I have my completed ice table, I'm going to take my Ka and calculate my hydronium, acetate ion, and my equilibrium concentration of acetic acid and solve for X. So I'm going to bring up 0.1 to cancel it on this side, and then take the square root of this number to get my X value. pH is going to be equal to the negative log of this value, and this is what I would get here. So this calculation you should be very comfortable with. We're going to think about a new situation when we add 10 milliliters of NaOH. So here, we're only going to add 10 milliliters, and this has 50 milliliters already. So I'm going to assume that this is going to be left over, and this is going to be completely consumed, meaning this will be my limiting and this is my excess. But I have to do the math to see what happens. And let's think about this balanced chemical equation. I'm going to be making, once I add 10 milliliters of this to 50 milliliters of this, my sodium acetate and water. So I need to think about what happens when this is all gone. I have a certain amount left over of this and both of these things in my Erlenmeyer flask after the reaction happens. This is my fun Erlenmeyer flask. Okay, we have a volume and concentration for our base. We have a volume and concentration for our acid. Our first step is to find the moles. Whenever you have an assessment, always make sure you find the moles first. Moles. Then you need to compare to identify the LR. Because this is a 1-to-1 ratio, I know because this is a bigger number, this is my excess, but you always have to show this comparison step on your quiz. So you're looking at how much NaOH you would make using the amount that you have of acetic acid. Because it's a 1-to-1 ratio, I'll have this amount of times 10 to the negative 3 moles of NaOH. This number is greater than the original, which is 1.0 times 10 to the negative 3. So this means that this is excess reagent and NaOH is my limiting reagent. Please review if you're confused about LR and how to find it. We need to use that. Now, in my third step, I'm going to calculate how much of my moles are left over of my acid, because I do have acetic acid left in my flask. So I take my excess, I subtract it from my used, and I produce an amount of moles that I have left over. But I can't put this number into my ice table because I need the concentration. I can only calculate the concentration by considering the new total volume, which is my 50 milliliters of acid and my 10 milliliters of base, which gives me 60 milliliters. I now have my concentration of my acid. I can put that right into my ice table. But because I did put some NaOH here, that means I produced some of this salt. So some of this is being produced, and it is a rule when we're before equivalence, we need to keep in mind that the moles of your base, because it's a strong base, is going to be equal to the moles of your conjugate base. So I have this amount from how much I put in from the 10 milliliters. I'm dividing by my total volume to get this amount. I can put that right into my ice table because I have some because I put in my strong base. Now, again, I'm still focused on my hydronium ion concentration because that'll help me find my pH. I have to check my approximation method for both, and it works out in this case. I'm going to solve for X by taking my Ka. I put in, this is my acetate ion, and this is my acetic acid concentration. I got this as my X value and this as my pH. Please review that, pause, ask me questions tomorrow, work through it today.